everyone, welcome back to the channel. Today, we're diving into the key topics in Python format specifiers and loops. These are foundational concepts that you'll use often in programming. Format specifiers help you control how your output is displayed, and loops allow you to repeat tasks efficiently. We'll be discussing different types of loops like while loops, for loops, and two important keywords used in loops: the break and pass statements. By the end of this video, you'll have a strong grasp of these essential Python tools. Let's get started. If you haven't had a chance to watch my previous video, I highly recommend checking it out. In that video, I walk you through the process of creating a project and cover essential Python basics in detail. You can find the link to that video above and in the description below. Additionally, I've included a link to the playlist where you can explore more topics and tutorials. Feel free to take a look if you're interested. So, format specifiers are an important tool in Python when you want to format and control how your output looks. Instead of manually concatenating strings and numbers, you can use format specifiers to dynamically insert values into strings in a readable and efficient way. The simplest way to do this is by using f-strings, which are a newer and easier way introduced in Python 3.6. Let's look at a basic example where we insert a variable into a string. In this case, name is the format specifier. It acts as a placeholder, telling Python to replace it with the value of the name variable. This makes your code cleaner and more flexible, especially when you have a lot of variables to insert. Now, what if you're dealing with numbers and you want them displayed in a specific way? For example, you may want to round a floating point number to 2 decimal places. Here's how you do that. Here, 2f is a format specifier that rounds the number to 2 decimal places. This is really useful when you need precise control over how numbers are presented, like in financial applications where you need to display currency values. Also, format specifiers let you control how much space a value takes up. If you want a number to take up exactly 5 spaces, you can do this. In the second print statement, you'll notice that I've added zeros before number 5. This format specifier pads the number with leading zeros, which makes up for the empty spaces. In contrast, the first print statement uses spaces to align the output. Although both methods achieve similar alignment, the second approach with zeros explicitly shows the padding characters. This can be particularly useful when you need to ensure numerical values are displayed with a fixed width and specific formatting. I'll now demonstrate how to use the less than symbol for left alignment in format specifiers. In the example, using 6 means the number will occupy 6 spaces with right alignment by default. If you want the number to be left aligned instead, you simply add the less than symbol. Here's how it looks. In this case, the less than 6 format specifier ensures that the number is aligned to the left within a field of 6 spaces. This can be particularly useful for formatting columns of text or numbers where consistent alignment is required. Now let's talk about loops, starting with the while loop. A while loop keeps running as long as the condition you provide is true. It's especially useful when you don't know exactly how many times you need to repeat a task beforehand. For example, let's say you want to count from 1 to 5. Here's how it works. The loop starts by checking if count is less than or equal to 5. As long as that's true, it will print the value of count. After each iteration, the line count plus equals 1 increases the value of count by 1. Once count becomes 6, the condition count less than equals 5 is no longer true, and the loop stops. The key advantage of a while loop is that it runs until the condition is no longer met, giving you flexibility for tasks where the number of iterations is not fixed. However, you need to be careful with your conditions. If the condition never becomes false, you could end up with an infinite loop that keeps running forever. Next, let's move on to for loops. A for loop is ideal when you already know how many times you want to repeat an action. You typically use it to iterate over a sequence like a list, tuple, or range. Here's an example of looping through a list. In this example, the for loop goes through each element in the numbers list and prints it. You can also use a for loop with the range function to loop over a sequence of numbers. Here's how you would loop through numbers 1 to 5. Another way to use a for loop in Python is by leveraging the range function. Let me show you an example. In this example, range 1 to 5 generates a sequence of numbers starting from 1 up to, but not including, 5. The for loop then iterates through each number in this range. This method is particularly useful when you know exactly how many iterations you need, making it ideal for tasks where you need to repeat an action a specific number of times or work through a sequence of values. By using range, you can efficiently manage and control the flow of your loops. Sometimes, you might want to use loops within loops, which is known as nested loops. Nested loops allow you to perform more complex iterations. For example, if you want to create pairs of numbers, you can nest one for loop inside another. Here, the outer loop iterates through the numbers 1 to 3, and for each iteration of the outer loop, the inner loop also iterates through the numbers 1 to 3. This results in every possible pair of I and j. Nested loops are useful when you need to work with multiple layers of data. Now let's introduce the break statement, which is a powerful way to control the flow of loops. The break statement allows you to exit a loop early, even if the loop's condition hasn't been met yet. Let's see an example. In this case, the loop is supposed to run until count reaches 10, but the break statement stops the loop when count equals 5. This is really useful when you want to end a loop based on a condition that might change during the loop's execution. In the console, you can observe how the break statement stops the loop when the count reaches 5. The break statement works in for loops as well. Here's how it would look. Once the loop finds the number 3, it breaks out of the loop, stopping the iteration early. This is particularly handy for searching through lists or arrays when you want to stop as soon as you find what you're looking for. The pass statement is another useful tool in Python. While it doesn't actually do anything by itself, it acts as a placeholder in your code. Sometimes, when writing a function or loop, you might need to leave part of the code unfinished but still want your program to run without errors. This is where the pass statement comes in. For example, in a loop, you might want to skip certain iterations but still continue with the loop. You can also use pass in function definitions or class structures when you haven't written the full implementation yet. Using pass allows you to keep the structure of your code in place without worrying about incomplete sections breaking your program. For example, in a loop, you might want to skip certain iterations but still continue with the loop. In this example, when I equals 3, the pass statement is executed. It doesn't do anything, but it allows the program to continue. This is useful for placeholder logic that you plan to implement later. You can also use pass in function definitions or class structures when you haven't written the full implementation yet. Using pass allows you to keep the structure of your code in place without worrying about incomplete sections breaking your program. So, that's a detailed breakdown of format specifiers, loops, the break statement, and the pass statement in Python. We've covered how to control your output using format specifiers, how to use while loops and for loops for repetitive tasks, and how the break and pass statements can help you control the flow of your loops and code. These concepts are key to writing efficient and readable Python code, and mastering them will take your programming skills to the next level. If you found this video helpful, don't forget to like, subscribe, and check out more Python tutorials in the playlist link below. Thanks for watching.